So let's walk through solving a few of these linear equations. We'll start with a really basic one. Something like x plus 4 is equal to 6. Now, remember the idea of solving these equations is to get the variable by itself, so to get the x in this case by itself. We can do this by doing algebraic manipulation, and as long as we do the same algebraic manipulation to both sides of the equation, we're in good shape. So in this case, to get the x by itself, I can just subtract the 4. However, I have to also subtract the 4 from the right-hand side of the equation as well, or else it's not equal anymore. So when I subtract the 4 here, that goes to 0, and I'm just left with an x on the left, and then 6 minus 4 is equal to 2. So that's the basic idea of what we want to try to do. Try to get the variable so it's by itself. X equals something, z equals something, or whatever variable we're using. So in this case, we ended up subtracting a number to do this. In a expression like this, 3x is equal to 12, we can get the x by itself by dividing by 3. So if we divide 3x by 3, the 3's will cancel out, and we'll just be left with x. But of course, we have to do that to both sides of the equation. So we have to divide 12 by 3 as well. And 12 divided by 3 is 4. So we get our solution there. Now we can take both of these ideas and combine them into a little more complicated equation. So something like this, 4x minus 5 is equal to 7. In general, for most of these equations, we want to follow the rule of adding and subtracting all the values we can first, and then using division and multiplication to get rid of the numbers that are multiplied or divided into the variable. So what I mean by that is, the first thing I want to take care of is getting rid of this minus 5. So I'll do this by adding 5 to both sides of the equation, and then negative 5 plus 5 is just 0. So I'll end up getting 4x is equal to 12, since 7 plus 5 is 12. And now that I've gotten rid of my subtraction here, now I'm just left with 4x is equal to 12, and then to get the x by itself, I can just divide by the 4, and I'll get that x is equal to 3. But in general, we want to follow this order. Get rid of any subtraction and addition you have first, and then take care of the multiplication or the division. Let's try another one. So 2x divided by 5 is equal to 3. In this case, I would like to get rid of this 5 in the denominator, so I can do this by just multiplying it by a 5 over here. So this is really the same thing as 5 over 1, and then this 5 divided by this 5 will cancel out. But if I multiply the left-hand side by 5, I also need to make sure that I multiply the right-hand side by 5. And so I'll end up getting 2x is equal to 15. And now I can just divide both sides by 2 to get rid of this 2. So divide by 2 on the left, and then divide by 2 on the right-hand side. And then I'll get that x is equal to 15 divided by 2 for my answer for this problem. You could have also thought of this another way. 2x divided by 5 is equal to 3. We could have rewritten this as 2/5 times x is equal to 3, because we can just think about if we multiply this x in, we'll just get 2x over 5. So we can pull the x out and we still have the same expression. In this case, I could have done it all in one step by just multiplying by the reciprocal, by 5 over 2, which would cancel out with 2/5 to make a 1, and then multiply by 5/2 over here. And we should get the same answer. 3 times 5/2, this is really 3 over 1. So 3 times 5 is 15, and then 1 times 2, of course, is 2. So of course, we did get the same answer. So sometimes there's a couple of ways to work the same equation. It's a lot of times you'll find 2 or 3 maybe different routes to go with it. So some equations we're going to have to do a little bit of work to them before we can start actually solving the equation. So for example, this one, I need to simplify it a little bit first before I do anything. So the first thing I'm going to do is just distribute this 2 like we did in the lesson last week, and I'll get 2y minus 6, 2 times negative 3. And then distribute the 4 over here, And so 4 times 2 is 8, and then 4 times 1/8 will be 4 over 8, or just 1/2. And now at this point I actually have two sides of the equation, both with a variable in them. So I can just do the same thing here. I can actually just subtract one of these from one side onto the other side. So for example, I might want to subtract 1/2 y from the right hand side. Of course, I also have to do that on the left hand side because we have to do the same things to both sides of the equation. Here these will cancel out, and then 2y minus 1/2 y is just 3/2 y. It's 2.5 y. And now I'm left with 3/2 y minus 6 is equal to 8. Now I can just add the 6 to both sides to get rid of the 6. So we'll add the 6 here, and we'll add the 6 here. And so I end up getting 3/2 y is equal to 14. And now I can multiply both sides by 2/3 to get rid of this 3/2. So 2/3 times 3/2 is 1. But of course, do that to both sides of the equation. So I end up getting y is equal to 14 times 2/3. This is 14 over 1. So I end up getting 28 over 3 for my answer. So some of these equations can get a little longer, and we have to do a few extra steps before we actually start solving the equation. This would be an example of a problem like that. Let's do one more. In this case, I also have to do a little bit of manipulation to my equation before I start to solve it. I'd like to combine these two fractions into one fraction. So we can do this by creating a common denominator of 12 for both of these fractions. So I can multiply, this is from last week, I can multiply 3 times 4 to get 12, and then I have to also multiply the top. And then I can multiply 4 times 3 to get 12, and I also need to multiply by 3 on the top. In this case, we're not doing that same thing to the right-hand side of the equation because we're only just taking these fractions. We're not really changing the fractions, we're just multiplying them by 1. We saw this method last week whenever we were starting to add fractions. So I'll get 4y over 12. 4 times y is 4y, 4 times 3 is 12. 3 times 3y is 9y, and 3 times 14 is 12, equals to negative 7. So now I have common denominators. I can add these. 4y plus 9y is 13y over 12. That's equal to negative 7. And then from here I can continue to solve. So I can multiply both sides by 12 to cancel out this 12. So we should get negative 84. And then on the left we'll have 13y. And now I can just go through and divide by my 13 on both sides. So that divide by 13 here will cancel out that 13, and then divide by 13 here. And I'll get y is equal to negative 84 over 13.